So today we're going to take a look at a few more methods of finding the derivative. And let's start by doing something that looks a little new, but we have actually covered it already. So I want to find the derivative of this fraction. And up to this point, we really only know how to deal with some cx to the n type function. And clearly this isn't in this form, but because there's a singular term in the denominator, that can be divided into each term in the numerator. So what I really end up with is 4x minus 7x to the negative 1 plus 8x to the negative 4, which is in this cx to the n form. So I can just find the derivative straight off from there. And I know f prime then is equal to 4 plus positive 7x to the negative 2 minus 32 x to the negative 5. And I can clean that up, but I'm just going to leave it as is. Now, in our next problem, we're asked to find the derivative of another fraction. But in this case, I don't have a singular term in the denominator, so I can't get this in some cx to the n form, which means we're going to need another method of finding the derivative. And that method's called the quotient rule. What the quotient rule states is if you have two functions such that f and g are divided into each other, then to find the derivative, you do the following process. You take the g function, which is on the denominator, multiplied by the derivative of the f function, which is the numerator, subtracted by the f function times the derivative of the g function all over the g function squared. So let's do that for the following problem. We're going to identify 3x squared as my numerator, so that's my f function, and that's 3x squared. My g function is the denominator, and that's x cubed minus 1. Find the derivative of both. F prime is 6x. G prime is 3x squared. And then we apply quotient rule, which once again is g f prime minus f g prime all over g squared. So let's go ahead and do that. G is x cubed minus 1 multiplied by 6x subtracted by 3x squared multiplied by 3x squared over x cubed minus 1 quantity squared. And clean that up. We have 6x to the 4th minus 6x minus 6x to the 4th, or sorry, I lied, minus 9x to the 4th all over x cubed minus 1 squared. That's w prime. So, adding like terms, I get negative 3x to the 4th minus 6x over, I'm just going to leave this because nothing's going to reduce cleanly, x cubed minus 1 quantity squared. And that is w prime. Let's do a couple more for practice. So in this case, we have an f value of x cubed minus 3x plus 1. Our g value is 2x minus 9. Take the derivative of both. F prime is 3x squared minus 3. G prime is 2. So then we do our quotient rule. Say h prime is equal to G F prime minus F G prime all over G squared. So let's simplify this a little bit. We get 6x cubed minus 6x minus 27x squared plus 27 minus 2x cubed plus 6x minus 2 all over. Again, I'm going to leave this because I don't think anything pretty is going to become of it. So now let's simplify like terms. We have 4x cubed minus 27x squared. 6x's go away. We have positive 25. And that's all over 2x minus 9 quantity squared. So now we're going to find the slope of the function at a point. So that means finding the derivative and then plugging the x value into the derivative. So once again, f is equal to x squared minus 1. G is equal to x plus 2. F prime is 2x. G prime is 1. H prime of x is equal to, once again, G F prime minus F G prime over G squared. So H prime of x is equal to 2x squared plus 4x minus x squared plus 1 over x plus 2 quantity squared. Clean that up a little. H prime of x is equal to x squared plus 4x plus 1 over x plus 2. And unlike the other problems, we aren't quite done because we want to find the actual slope at the point 2, finding an instantaneous rate of change or a slope. So we're going to find h prime of 2, which is 2 squared plus 4 times 2 plus 1 over 2 plus 2 quantity squared, which gives us 4, 12, 13 over 4 squared, which is 16. And that's the slope. So in this function, you'll notice we have the sum of two functions, one of which is a fraction. I'm going to independently take the derivative of each term and then add them together. So for this second function here, call this w if you will, we'll say the f is 2 and the f prime is 0. The g is 3x plus 1, and the g prime is 3. So therefore, I have g, we'll say this is w prime, g f prime minus f g prime all over g squared. So this will go pretty quickly because you'll notice we have 0 times something in this case. Which gives me negative 6 over quantity 3x plus 1 squared. That's w prime. The derivative of this term, let's just call this is j prime is just 2x. So if I want h prime, I just take and add the two derivatives together. So I have 2x minus 6 over 3x plus 1 quantity squared, and I think I'd let that go. You could find a common denominator, but no need in this case. So that's all we've got. Make sure you fill out your lesson summary, and we'll chat tomorrow.